Hello again, and here's the example that I was talking about. Here, this is the reaction between iron and sulfur producing iron sulfide. As you can see, this is a 1-to-1 ratio reaction where for every one iron, it reacts with one atom of sulfur, producing one molecule of iron sulfide. You'll begin to see the problem when we look at these masses up here. Here you can see iron, each atom has a mass, a relative mass of 56, whereas iron has a relative mass of 32. So in this case, iron's a bit analogous to our polo mint, and our sulfur is analogous to our Tic Tac, where the Tic Tacs are lighter, the polo mints are heavier. So again, if I was to weigh out equal quantities in grams, let's say for instance 10 grams and 10 grams, you should notice that actually because sulfur is lighter, I would have lots of these left over and would run out of my iron. So how do we get around this problem? Well, if you look above, if I was to weigh 56 grams of this and 32 grams of this, I would have the equivalent of 1 mole of each. And that's what I need. I need 1 mole to react with 1 mole. And in turn, this would produce 1 mole. So how on earth, what is this idea of moles? Well, quite simply, what we would do is use this formula, and it's Mr. M mole, where this is our number of moles, this is the mass we need to weigh in grams, and this MR is the relative formula mass. In this case, the MR of iron is 56. So if I need 1 mole, and that's what the ratio is, 1 mole to react with 1 mole, can you see that if I need 1 mole, then actually the mass I need to weigh out is the MR, because the mass that I need is my MR times my moles. So therefore it's going to be 56, and I need 1 mole because it's a 1-to-1 ratio. So therefore, if I was to weigh out 56 grams, and then do exactly the same for sulfur, how much do I need? Well, the mass that I need is it's MR times the mole. So the MR of sulfur is 32. And again, I need 1 mole because it's a 1-to-1 ratio. That means I would need to weigh out 32 grams. And if I weighed out 56 grams of iron and 32 grams of sulfur, they would react perfectly because they have the same number of particles, and I'd have none left, and I would end up with 1 mole of iron sulfide. So that's a brief introduction to moles. So it's really important as chemists that we work in this term of moles, because 1 mole of any substance, I could be talking about a mole of cats, a mole of peanuts, a mole of pound coins. When I'm talking about a mole, I'm talking about the same number of particles, and 1 mole of anything will contain this number, which is Avogadro's number. It's a special number and it's huge. 1 mole of anything will contain 6.02 times 10 to the 23 particles. And this number is obviously written in standard form. And I've written the number out for you longhand. That is just how many particles there are, or number of atoms or molecules there are in 1 mole of any substance. So let's go back to our iron sulfide example where it's a 1-to-1 ratio. If I've got some iron and I'm reacting it with sulfur, and it forms iron sulfide. What this is telling me is this is a 1-to-1 ratio. So therefore, if I'm working in that ratio and I was having 1 mole of iron and 1 mole of sulfur, then I would have to have that many particles. And in order to work out how many grams I would need, that is where I have to use my Mr. M mole formula. So here is your first task. I'm going to go through A as an example. So in this question, we are asked to calculate the number of moles of each of these substances. And it's asking you to give the answers to 3 significant figures. So let's look at this first example. 90 grams of water. Well, we know our formula and we remember it as Mr. M mole. So in this question, we're actually asked to find the number of moles. So in order to calculate moles, it's simply you take the mass in grams and you divide that by the MR. So let's look at this first question. Well, here I can work out my number of moles. I have 90 grams and I'm going to divide that by the MR of water. Now my previous tutorial showed you how to calculate the MR of these, but I'm just going to do a refresher. H2O. If you use your periodic table, oxygen has a relative formula mass of 16. Hydrogen is 1, but there are 2 of them. So 2 times 1 add 16 equals 18. So I now know the MR of water, which is 18. So I'm going to divide my 90 by my 18. You would take a calculator, take 90 and divide that by 18, and I would have the equivalent of 5 moles. What I'd now like you to do is go through B, C, D, E and F. I'd then like you to pause the video and I'll bring the answers up on the screen and then you can get ready for task 2. Just before you move on to the task, I have just noticed that I've done a silly error, that actually when we're calculating things to 3 significant figures, you noted that I said we do 90 divided by the 18 gives us 5 moles. Well, that's actually to 1 significant figure. Nick needs to read the question properly. So in terms of 3 significant figures, I would need to write that as 5.00 moles. So now you're actually ready to have a go at B, C, D, E and F. So pause the video now, have a go at them and replay it when I will show you the solutions. Sorry about that. Thanks. Welcome back, and here are the answers for task 1. What I'd like you to do is pause this video in a second and check whether or not you've got the right answers and make any corrections that you need to make sure you actually end up getting that correct answer. One common mistake is students can use the formula, but what they don't do correctly is calculate the relative formula mass for the compounds. If this is still a problem, then what you need to do is revisit the tutorial that I made earlier on in the week in how to calculate relative formula mass and have another go at seeing if you can get the correct relative formula mass for each of these compounds. So pause the video now, check your answers, make any corrections that you need to, and then I'll introduce task 2. Pause the video now. Hello everyone and welcome to task 2. In this task, you are required to calculate the mass of each of the following substances and to give your answer to 3 significant figures. So let me have a look through this first example for you. So we want 4 moles of nitrogen. What would I need to weigh out if I wanted 4 moles of nitrogen? Well, the first thing I need is the correct formula. So again, using my formula triangle, which we know now as Mr. M mole. This time I'm required to calculate the mass. How many grams do I need to weigh out for a specified number of moles of a molecule? So let's look at this first example. If I want to calculate the mass, it's the MR times the moles. So the mass is equal to the MR times the number of moles that I need. Well, the MR of nitrogen is N2, so that's going to be 2 lots of 14. Nitrogen has a relative atomic mass of 14, so that would give me 28. So the mass that I need to weigh out is going to be 28 times, well, I want 4 moles, so that would be 28 times 4. So if I pick up my calculator, 28 times 4, that would give me 112 grams. And as you can see, this is correct to 1, 2, 3 significant figures. I'd now like you to have a go at B, C, D, E, and F. Pause the video, have a go, and then when you start the video going again, I'll have the answers ready for you. Good luck. So welcome back everybody, and use this as an opportunity to check your answers, mark them, see where you made some common mistakes. There is going to be one final task after this. It's a short task, but I would like you all to have a go at it. So please pause the video now and use this as an opportunity to correct your answers. Make sure that you've got these MRs correct, because without those, you're never going to get the right answer. So pause the video now, check your answers, make some corrections, start it again in a second for task 3. Hello and welcome back to your final task. In this task, you are required to calculate the MR. So again, in this task, you're going to need to use your formula triangle, but this time I'm not going to write it out for you. You're going to have a go yourself. And then when you finish this task, I'd like you to look through this self-assessment, maybe copy this grid out and actually have a look through it, read it carefully, and do a self-assessment whether or not you feel that a particular skill is a strength or an area to develop. Then with any tick that you put in the areas to develop, have another look through these videos and see if you can turn it into a strength by practicing and having a look through and maybe reviewing some of the mistakes that you've made. So pause the video now, have a go at this task here and have a go at doing the self-assessment. And I'll be back with the answers. Pause the video now. So here are the answers for task 3. You were asked to calculate the MR, the relative formula mass of the compound. So again, I'm going to copy out the triangle. This is a triangle that you need to learn, Mr. M. Mol. And in this question, we are required to work out the MR. That's what we need to work out. So using this triangle, the MR is equal to the mass divided by the number of moles. So in this question, we have 1.64 grams and we have 0.02. If you were to do that calculation, obviously you'd use a calculator, it would be 82. But we want it in 3 significant figures, so it would be 82.0. And the units would be grams per mole, G/mol. I hope you found these videos useful and I look forward to speaking with you next time. Bye for now. Keep yourself safe.